So on this one, they're asking us to use synthetic substitution to find f of negative 4 and f of 3 for each function. In this case, we only have one function. So when they give you this notation, f of negative 4, that means take the negative 4 and plug it into your f of x function. Here's your f of x function. The way to plug it in is put in a negative 4 right there where this x is at, where this x is at, and so on and so on. So the first thing to do would be to rewrite it, but instead of x's, put parentheses. And let's, of course, plug in negative 4. And you could even use calculators, so it's really easy. Negative 4 to the third power, that's going to be negative 64. And let me ask you this. Should I change these guys to a plus plus?
Yeah.
No. No. Why not? Because you need to do exponents first before multiplying. Because see, the only reason why we change a minus to a plus plus is because it's kind of like having a negative 1 times a negative 4. A negative times a negative becomes a positive. The reason why you don't do that is because you have to do exponents first. So negative 4 to the second power is really positive 16, right? But then that negative in the front is going to make it back to a negative 16. So do not change the minus to plus, because you're going to end up with a plus there, and that's going to be incorrect. It's really a minus. And then over here, you really do have negative 7 times negative 4. That is positive 28. Bring down the plus 2 at the very end. And as we work this out, this becomes negative 80, I believe, plus 28 plus 2 equals negative 50, huh? And that's the answer for f of negative 4. We still need f of 3, okay? So, So let me go up here and plug in 3. So you're going to have 3 cubed minus 3 squared minus 7 times 3 plus 2. So plug in 3 right here, plug in 3 right there, 3 right there. 3 to the third is 27. 3 squared is 9. 3 times 7 is 21. Plus 2 at the very end. So 27 take away 9. Minus 21. That is 3 plus 2. That's negative 1, correct? Check me, please. Yes? So that answer is negative 1. So f of 3 equals negative 1. So you have your two answers, negative 5 and negative 1. Oh, not negative 5, negative 50. I'm sorry. Yeah, negative 50, not negative 5. F of negative 4 gave us negative 50. F of 3 gave us 1. Negative 1. Gosh, sorry. Okay, number 11. Given a polynomial and one of its factors, find the remaining factors of the polynomial. So they want us to factor this, but they're giving us one of the factors. One of the factors is x plus 3. Everybody copy this down, please. And you also want to write down the instructions that they're giving you one of the factors. And they want you to completely factor it. So given a polynomial and one of its factors, find the remaining factors. So this is where we apply the remainder theorem. Remember, if something is a factor of something else and you actually go through the division, there should be no remainder, right? It should be 0. So we know that 8 is divisible by 4. There's not going to be no remainder. 4 is a multiple of 8. 4, 8. So right here, we have this polynomial. We know one of its factors. So if I set up synthetic division, I know I'm going to put a negative 3 right here. I know that my remainder over here should be 0, right? So let's set it up. And how do we set up these numbers over here? You go with the coefficients of all of them from top all the way to the bottom. From the leading coefficient with the highest exponent all the way down to the bottom, the constant. So we really have a 1, a negative 1, a negative 8, and a 12. So as you go down, you add 1 plus 0, because there's nothing there, is 1. And then you take the negative 3 and multiply it by 1, and you get negative 3 up here, correct? And then, as you go down, you combine negative 1 minus 3, what do we get? Negative 4. And then as we go up, we multiply negative 3 times negative 4, we get positive 12. And as we go down, we combine negative 8 plus 12. That's 4. Well, let me do that in blue, sorry. Stay consistent here. Negative 3 times 4 is negative 12. And of course, we know that 12 minus 12 is 0. But we already knew that because of the remainder theorem. We know that if it's a factor, we know the remainder is going to be 0. So why the heck did we actually go through and do this? So we could actually take this new coefficients and make a new remaining polynomial. Okay? So I already know that x plus 3 is a factor. They gave that to us. X plus 3 is a factor. But what we have down here is the actual remaining polynomial. So what would that be as a polynomial? 1x squared minus 4x plus 4. Yay? So if it was an x to the third to start, there's going to be 1x squared minus 4x plus the constant at the very end. X squared minus 4x plus 4. Now the question is, could you continue factoring here? You cannot, right? When you think 4 times what is 4, that if you add together is actually you could. You could. X minus 2, x minus 2. Sorry, it's Monday. So you could continue factoring x minus 2, and the original that they gave you, x plus 3. So when they say find all of the remaining factors, so they already gave you this one. They don't want to include that in the answer again. They want you to find the remaining factors. So what your answer is going to be is x minus 2 times x minus 2, or you could even write it as x minus 2 squared. I don't remember exactly how they write it on the multiple choice, but we know that these are the remaining factors of the original. So let's take a look at this next one. This next one's fun. Please copy it down. Okay, so on this one, the multiple choice answers, all 4 of them are going to have a certain answer, x equals negative 3. Okay, so once you notice that they all have the same answer, x equals negative 3. Now, of course, they're all going to be different, like x equals negative 3, x equals 5, x equals 2. The other one's going to be x equals negative 3, x equals 7, x equals negative 1. But once you notice that all 4 of them have the x equals negative 3, you could use that to your advantage because you know that one of the answers has to be negative 3. So the thing to do would be to use synthetic substitution, knowing that if you plug in negative 3, you should get out 0. So when you plug in negative 3 with synthetic substitution, and you go to your coefficients of each of the terms up there, you're going to have a 1, a 2, a 1, an 8, and a negative 12. So as you go down, you add 1 plus nothing is 1. As you go up, you multiply. Negative 3 times 1 is negative 3. As you go down, you add 2 plus negative 3, that's negative 1. As you go up, you multiply. Negative 3 times negative 1 is positive 3. As you go down, you add 1 plus 3 is 4. As you go up, you multiply. Negative 3 times 4 is negative 12. As you go down, you add positive 8 and negative 12 is negative 4. And as you go up, you multiply. Negative 3 times negative 4 is positive 12. And of course, the remainder is 0, but we already knew that. Okay? This is synthetic substitution. If we plug in, see, we know negative 3 is an answer because when you look at all your multiple choice answers on the test, they all have the common answer, negative 3, so you know that that's for sure an answer. Now, if you know for sure that that's an answer, that means that if you plug in a negative 3 here, negative 3 there, negative 3 there, negative 3 there, your answer will be a true statement, which is going to equal 0, right? So that's why when you plug in negative 3, when you substitute, you're not going opposite. This is an actual answer, right? Now, if you had it in factored form, it would be x plus 3. That's where you'd plug in the opposite, which would be x minus 3. So synthetic substitution, plug in that exact value, x equals negative 3, work it all out, you'll see that the output is 0 right there. It's a true statement. So what we do now is take this remaining, these numbers, and write your remaining polynomial. Okay? So we know that x plus 3 is a factor because x equals negative 3 from observing our multiple choice answers. So this next one is going to be an x to the third. So we now have an x to the third minus x squared plus 4x minus 4. And we need to continue factoring. So a method of doing that in this case would be to take those 4 terms and factor by grouping. Okay? Or you could continue to test values using synthetic substitution. But I recommend to just go straight to grouping. So I'm going to take that, bless you. The first group, what could I pull out of my first 2 terms? X squared. So if I pull out an x squared, what's going to be left, Ariana? That's right, an x minus 1. Thank you for your participation. Okay, and how about the second group? What could I pull out of the second group? Right here, 4x. You can pull out a positive 4. So let's pull out a positive 4. And what's going to be left inside the parentheses? X minus 1 also. And that's great because this binomial in the first group and that binomial in the second group is in common, which means you could pull out that common binomial of x minus 1. And what would be left over? An x squared plus 4. Okay? So let's understand that this polynomial up here, this quartic polynomial, you could rewrite it as x plus 3 times x minus 1 times x squared plus 4. So if I actually do that, write it as x plus 3 times x minus 1 times x squared plus 4. And we know that it's equal to 0, right? All we did was factored the original quartic polynomial to look like this, reverse distributive property. If I were to distribute combined like terms, I'd get back to this. So why did I do this? Why did I write it in factored form? Because now I could split it and solve, right? And we'll be able to find our answers. By the way, this one, you might think, oh, maybe I could factor this further, but you can't. If it would have been x squared minus 4, then yeah, you could break it down to x plus 2x minus 2. But x squared plus 4, you can't break it down any further. That's as far as you could factor. So when you split each of them, set them each equal to 0, right here, x plus 3 equal to 0 is going to give you the answer x equals negative 3. When you set x minus 1 equal to 0, you're going to get x equals positive 1. And this is an interesting one. When you set x squared plus 4 equal to 0, you're going to subtract 4 on both sides, and you'll get x squared equals negative 4. And how do I get rid of the square? You square root. So when you do to one side, you do to the other. So you're going to get x equals, and when you apply a square root, you're going to have to put a plus minus right in front of your answer. And what is the square root of negative 4? 2i. Okay? So on number 12, the instructions say solve the equation, state the number and type of roots. Okay, well, let's solve the equation. We did that. Our answers are x equals 1, x equals negative 3, which we actually recognize that answer just by looking at the multiple choice answers. And we also have 2 more answers, the plus or minus 2i. So that would be the answers, and it also says state the type of root. Well, you have 2 real, 2 imaginary. You would add that on, or you would have that on your multiple choice answers. 2 real, 2 imaginary.